Okay, so then let's do Remote Learning 15, Part 2, and I will definitely be using the information from part number 1, which is completing the square, this crazy process of generating a super important algebraic structure known as the binomial square. All right, in part 1, we used the binomial square to then solve the quadratic. And now we're going to use the binomial square for some other purposes. Okay, so I need to remind you of something from the previous chapter on graphing quadratics, and that is the vertex form. So if you can follow the cursor over here, I have taken a section from the book which is a synopsis of the vertex form. Okay, so this is what the vertex form looks like. The parent function is over here in blue. I suppose it's not the parent function, but the parent function would be when a is equal to 1. But this is a parabola whose vertex is at 0, 0. And the idea of the vertex form is if you take this blue one and you mess with the x by adding or subtracting something that moves it left or right. Now, we were dragging things on Geometra Sketchpad at one point, and we found that if you um, have x minus 2, it drags it to the right 2, so that the item that's being subtracted is the uh, uh, place where the vertex moves to. I'll do an example in just a second. Okay, but this item that's attached to the x tells us how it moved left or right, and then this item that's added and or subtracted at the end gives us information about how it's moved up and down. So a combination of analyzing h and k will then tell us where the new vertex is. Thus, vertex form. Okay, so let me remind you, and we'll come over here and do this one. All right, so I'm going to write it in a bit of a strange way to overemphasize this subtracting component right here. That's my weird way of writing plus 2. And the reason I'm doing that is because now if you match up the formula, h is the thing that's being subtracted, so it's negative 2, right? We talked about the opposite game, so the plus 2 becomes minus 2 on that one. But then that's not true for k. K is just whatever that number is. Between those two pieces of information, I now have the vertex, negative 2, comma 3. I also know that a is negative 2, so it opens down. And I know that it's twice as steep. Okay, so this was a fairly significant part of Chapter 8. I'm going to go ahead and graph it now. And let's build a grid system. Put it over here. And oops. All right, then let's go and plot the vertex, which is negative 2, 3. There's negative 2, 3, big old V for vertex. I know it opens down, so it's going to do this kind of thing. And I also know it's twice as steep. So here comes twice as steep. It would normally go 1, 1, 2, 4, but now it goes 1, 2, twice as much, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, axis of symmetry. And therefore I can get this point and that point. Okay, so here is my parabola. All right, so I'm also wanting to remind you that this vertex is the coordinate negative 2, 3, and 3 is the maximum height that the parabola ever goes. It goes up to 1, 2, 3, and never higher. Okay, so we refer to this as the maximum value, and that is equal to 3. It's true that -2 is what would be put into the function to get out 3, but the maximum value is 3. So it's the y-coordinate of the vertex. On a parabola that opens down, we have a maximum, and on a parabola that opens up, like this red one, then we have a minimum value, and this minimum value would be whatever k is. Okay, so reminding you of some situations from chapter 8, namely the vertex form and this concept of maximum and minimum value. I'm going to need that going forward. Okay, so I'll read to you this paragraph, and then I'll tie this into what we did in part 1. That is completing the square. One way to find the maximum or minimum value of a quadratic function is to write the function in vertex form. Just reviewed that. By completing a square. Just taught you that. Recall that the vertex form of a quadratic function is, here it is again, a cannot be 0 because then it kills everything out and you get a flat parabola or just horizontal line. So that's just a little technical piece. And the vertex is at hk. Opposite game on this one, just the regular number on that one. Okay, so we're going to move things into vertex form so that we can find maximum and minimum values. But the way you move it into vertex form is you do it by completing the square. Okay, why? Let's see. Okay, well, the answer to why is because the vertex form has a binomial square as part of its feature. And this doesn't have a binomial square. So this is standard form. And it's good for a lot of stuff. And we can go find maximum and minimums. We use a little tiny formula, -b/2a, and it required some work. Okay, but I'm just going at it a new way now by using the ability to rewrite this standard form one into vertex form, and then I can just pluck out the numbers. All right, but the way you rewrite the standard form into vertex form, since vertex form has a binomial square, is you have to make a binomial square out of this, and that's what completing the square does. Phew. Okay, so let's do it. Completing the square. All right, so it's slightly different because there's a y feature running around, but it has a lot of the same characteristics. Like we're going to clear out the constant. Well, okay, so I'll bring it over there. And then I'm going to make sure that it's 1x squared, and it is. So I don't have to divide by anything. I'll just leave that be. Okay, so next you go off to the side and do the usual moves. That's that you grab +4 and you chop it in half. You grab the b value, the coefficient of the x, this number, the x's number, right? Okay, and then let's see, we get 2, and then you take that number and you square it, and so then I have 4 there.